All right, everybody. We're on day 15 now, which is actually our second day of graphing. Uh, on day 13, our first day of graphing, it was circles. All right, a lot of different circles we ended up with. Now, what we're going to do is, all right, let's tag on a plus or minus a number to it. Okay, so if I had given you guys this one I'm boxing in purple here, 5 sine theta. Last time, that would have been a circle on the y-axis right here. Okay. Now you're putting a negative sign in front, so that's going to end up flipping it somewhere here. But now that I put the 5 minus 5 sign, now that's going to affect the graph a little bit more. Okay. So let's see. I'm going to do it the same exact way, which is going to put everything in my calculator and graph it using the table. All right, so let's go through a little review again. Calculator time, make sure it's in radian mode, please. Please make sure your mode is in radians. Okay, so here we go. Let's plug in 0 to our equation. So we have 5 minus 5 sine of 0, and that comes out to be 5. So I'm going to plug a 5 in here. So that means it's going to be 5 comma 0. Which would be, let's see, here we go. 1, 2, 3, 4, 5 right there. 5 units away on 0. All right, let's keep grinding here. Next one, I got 5 minus 5 sine. Let's get a fraction template up. Pi over 6. It's nice to have the calculator. Now I'm looking at 2.5. 2.5. Oops. So 2.5, so it's going to be 2.5 comma pi over 6. Okay, so again, go over to about 2.5. Do your best. So let's see, 1, 2.5 right there. All righty. And also make sure here, last time it came out to be a circle, so it wasn't that big of a deal, the order of the points, because I just drew a big circle through them. Now we got to start getting a little bit more detailed where here's my first point and I have to make sure I connect it to the second point. Okay, because that's going to be key here because our points are going to be in different spots than just a circle. All right, so let's keep going. Pi over 3 now. 5 minus 5 sine pi over 3. You guys can probably do this quicker than I am. All right, so we're looking at about 0.67. I'm going to write down 0.67. So 0.67 comma pi over 3. So here we go, about 0.67, which is a little less than 1. So about right there. All right, let's keep connecting them here. Let's make sure we know where our points were. All right, let's keep going. Pi over 2. 5 minus 5 sine alpha y equals pi over 2. 0. Look at that, 0. So I'm going to do 0 pi over 2. Now, where's that point going to be? That's going to be right at the pole. Right? That's going to be right at the pole, 0. So we connect that one. Let's keep doing a couple more here. I'm going to start skipping the calculator, guys, because I have the values already written down. You guys are seeing how I'm doing on the calculator, so I trust you guys know how to do this on your own. So let's go through the table. It goes a little quicker, and we can plot them. So at 2 pi over 3 will also be 0.67. So you'll have 0.67, 2 pi over 3. So graphing that one at 2 pi over 3. 2 pi over 3, right just below 1. So there we go. All right, next one's going to be 2.5 again. So you guys are looking at 2.5 comma 5 pi over 6. Okay, so let's go to 5 pi over 6 and graph out the 2.5. So 1, 2.5. So right here. All right, let's keep going. 2.5, 5. So I'm at 5 comma pi. So let's go on at pi. Let's go out to 5. 1, 2, 3, 4, 5 right here. Again, order matters. All right, and then 7 pi over 6 is 7.5. So that's 7.5 comma, what was it again? Get out of there. 7.5, 7 pi over 6. Okay, so that'll be 7 pi over 6. Okay, let's count it. 1, 2, 3, 4, 5, 6, 7.5. There we go. All right, keep going. Next up, 3, that's going to be 10. So we're at 10 comma 3 pi over 2. So this is going to be all the way out here at 10. And then one more point we have is going to be 9.3. So 9.3 comma 5 pi over 3. All right, so let's graph that one. So 5 pi over 3, here we go. 9, almost to 10, so right about here. Connect it. And then connect it back to the first point. And yes, it is similar to a heart. Only time that'll come up this year for me, having a heart, that's for sure, is on a piece of paper, not inside my body, that's for sure. All right, so it's called, actually, this is if you want to start impressing your friends or as somebody at the dinner table tonight because you're not going anywhere. It's called a cardioid graph. Cardioid, cardio for heart, cardioid graph. Again, what I recommend is checking your answer on Desmos, or do this, or check it even before you start graphing. Say to yourself, all right, I'm going to graph this on Desmos. Here's what it should look like. So I go to my polar grid. Again, this equation is r equals 5 minus 5 sine parenthesis, type in the word theta, and there it is. There's our graph. Looks pretty good to the one we did there. All right, so it matches. Okay. All right, so nice job on that one. Let's go to our last one, which is 1 plus 4 cosine theta. All right, so again, if I learned any patterns from my first day of graphing, I know this right here is going to be a circle on the x-axis. So going out to 4, so something basically looking like that. But now that I add 1 to it, how does it affect everything? Okay, how does it affect everything? I'm going to do the same thing I just did for the previous one. I know you guys can plug things into your calculator and you'll do that for the assignment. So I'm just going to fill in the table here for you. All right, so because this is going to be an interesting graph here. So this is going to be 5. So I'm going to add 5, 0. And let's fill in the table on this one first, all right? 4.5, 4.5 comma pi over 6. 3, 3 comma pi over 3. 1, so 1 pi over 2. Negative 1. All right, so we're going to have to talk about where do I go now. Negative 1 comma 2 pi over 3. 5 pi, negative 2.5. 5 pi over 6. Negative 3. Negative 2.5. 1 and 3. Okay, so here we go. Here we go graphing this. We'll do it in yellow this time. All right, so I got 5, 0. So 1, 2, 3, 4, 5, 0. And it kind of makes sense, right? Think about this, guys. If I graphed it without the +1, it would go out to 4. But now +1 says, oh, move it out one spot further. So now I'm at 5. Makes sense. Pi over 6, 4.5. So about 4.5 right there. I'm going to try to connect them as I go. 3, pi over 3, 3. So 1, 2, 3 right there. 1 at pi over 2. -1, 2 pi over 3. Okay, so now 2 pi over 3, but since it's -1, remember, you guys got to go on the opposite side, right? If the r value is negative, I go on the opposite side of the angle. So at 2 pi over 3, I'm going to go on the opposite side and graph it at 1. So right, my eye's always right there. Okay, on the opposite side. Now negative 2.5, so at 5 pi over 6, okay, at 5 pi over 6, now I want to graph negative 2.5, so you go on the other side of 5 pi over 6, which will be, let's see, that's 1, 2 away, 1, 2 away. Yep, right there. So really at 11, so 1, 2.5. There we go. Okay, doing our best here. -3 pi. So now I'm going to go, instead of pi, it's going to be at 0. So at 1, 2, 3 right here. Keep connecting. -2.5, 7 pi over 6. So here we go, -2.5, 7. So again, -2.5, you go on the other side of 7 pi over 6, right? Other side. So I'm going to go up here to pi over 6 and graph 2.5. So it's starting to come outside to inside now, which is what it should be happening. And then next up, what's up now? 3.2 comma 1. All right, so it's kind of got a little loop in the middle, right? And then 5 pi over 3, 3. 1, 2, 3 right here. And then I'm coming back to the beginning. There it is right there. Look at that beaut. So maybe you're, I don't know, we've never graphed anything that looks like this. All right, let's check it then, right? We can always check it on Desmos. Let's go see if we did it right. So we go back here. So we just graphed 1 plus 4 cosine theta. And look at that, guys. There it is. Looks pretty darn close to what we had there. All right, so very nice job there. All right, so keep using your chart. Make sure your calculator's in radian mode. And then now when you're adding and subtracting a number to it, be prepared for something a little different now. Okay, but always check it on Desmos. All right, guys, looks like you guys have 2 graphs here. All right, 2 graphs to do. All right, so I think you could handle it. I'll talk to you guys later.